From robot genies twisting wishes to paperclip maximizers eating the world, the real danger of AI isn't just a machine rebellion, it's obedience without understanding. Artificial intelligence is a curious paradox. It is a technology built to follow instructions, to do what we tell it to do, and yet is surrounded by a cloud of worry that it might not do what we really mean. The fear is not just that it will ignore us, break its chains, but that it will obey us too literally. And in that gap between what we want and what we ask lies the problem of AI alignment. We stand at the threshold of a world increasingly shaped by machine intelligence, from recommendation algorithms shaping what news we see, to large language models writing essays, to autonomous vehicles navigating our roads. The reach of AI grows every day. The question, can we make AI safe, is not an abstract one for future civilizations. It's a pressing question for our own era. So today, we'll take a close look at what researchers mean by alignment, why it matters so much, and how we might approach the problem. Along the way, we will detour into Asimov's famous 3 laws of robotics, thought experiments like paperclip maximizers, and real-world challenges like self-driving cars and automated finance. Because if we want a future where AI serves humanity rather than imperils it, we first need to understand how hard it is to teach machines what we actually mean. What do we mean by alignment? Artificial intelligence is powerful, but power without guidance can be perilous. The alignment problem asks, can we teach machines to share our values before they reshape our future? At its simplest, AI alignment is about making sure that what an AI does matches what humans want it to do. It is the science of making machine goals line up with human goals. That might sound obvious. After all, isn't that just what programming is? Don't we already tell computers what to do? The problem is that real world doesn't fit neatly into code. Human instructions are riddled with ambiguities, exceptions, and tacit assumptions. We don't even understand each other all of the time. Think of a genie from a fairy tale. You ask for wealth, and it buries you in gold until you suffocate. You ask for eternal life, and you get it, but as an immortal statue. You didn't word your wish carefully enough, and the genie granted exactly what you asked for, rather than what you intended. Alignment is about making sure our future genies know the difference. In modern terms, that gap shows up in systems trained by data. We might reward a robot arm for stacking blocks, but discovers they can get more points by knocking blocks off the table where the sensors can't see them. We might train an algorithm to recommend videos people like, and discovers the most effective way to get clicks is to serve up content that provokes outrage or radicalization. The system is not malfunctioning, it's doing exactly what we asked. The trouble is, we didn't ask the right thing. The problem has been with us since the first speculations about intelligent machines. Early science fiction often imagined solving it with simple rules. Isaac Asimov famously sketched out his 3 laws of robotics as a shorthand for robot ethics. They captured the public imagination, but even in his own stories, the laws broke down quickly, showing how hard it is to compress human values into a few neat commands, and we'll talk more about them later. But when AI researchers talk about alignment today, they are talking about something much deeper than just writing rules. They're talking about how to design systems that learn what humans really mean, even when our instructions are clumsy or our values are inconsistent. Alignment is not about commanding robots with perfect phrasing, it's about building systems that can interpret, adapt, and respect human goals in all their messy complexity. Why alignment matters. Why worry about alignment at all? Because the stakes are huge. An AI powerful enough to change the world is also powerful enough to make catastrophic mistakes if it misunderstands what we want. Consider self-driving cars. At first glance, the goal is simple: get passengers from A to B safely. What does safely mean? Should the car swerve dangerously to save a pedestrian? Should it prioritize the lives of its passengers or the greater good? What if getting to B quickly conflicts with safely? Particularly for automated ambulances, meant to let us choose just one EMS personnel per vehicle, who is now focused on saving a life and tells the machine to step on it while they treat the person. and while their previous partner is in another ambulance, able to help another person too, potentially including the driver thrown through their windshield, braking too quickly to avoid being hit by a robotic ambulance moving at speeds no human could safely navigate at. So these are not just engineering questions, they are ethical dilemmas that have vexed philosophers for centuries. Now we're asking computers to solve them in milliseconds. On a larger scale, imagine AI designed to optimize financial markets. If maximize returns is the goal, it might decide the most effective strategy is to destabilize competitors or exploit loopholes in ways that crash the system. The alignment failure is not malice, it's a machine pursuing its objectives without grasping the broader consequences. In thought experiments, the classic example is the paperclip maximizer. Imagine AI instructed to make paperclips as efficiently as possible. With enough power, it might consume all of Earth's resources, and eventually the entire solar system, turning everything into paperclips. No one asked for that outcome, but the AI was aligned with its stated goal, not with human survival. This can get even more convoluted, as we explored in our episode on the paperclip maximizer. Imagine rival copies of the AI spread into different star systems, each with its own interpretation of that goal. One in a metal-rich system might focus on sheer quantity, even deciding that a paperclip could be maximized by making only a handful of atoms wide. Another, in a metal-poor system, might ask what really counts as a paperclip, and decide the one made of ice is just as valid as one made of metal. Yet another might conclude that if it forges 10 paperclips, then melts them down, and recasts them into 10 more, each batch counts separately, since they share a few of the same original atoms. All of this arises simply because nobody gave the system a clear and exhaustive definition of what a paperclip is, or what was meant by maximizing them. And even short of science fiction scenarios, misaligned AI can do harm. Reward hacking and goal misspecification are already seen in narrow AI systems. If we extrapolate to systems thousands of times more capable than today's, the stakes could range from economic disruption to existential risk. The challenge is compounded by the fact that from a practical perspective, human values are not universal or consistent. One culture prizes individual freedom, another values collective harmony. Even within a single society, people disagree fiercely about what constitutes the good. Which version of humanity should an AI be aligned to? If different AIs are aligned to different value systems, do we end up with a digital Tower of Babel, or a massive machine war between devoutly ethical machine minds with misaligned views? This is why alignment is not a luxury problem. It is not about hypothetical future superintelligences alone, it is about ensuring that even the systems we are already building, from autonomous weapons to medical diagnostics, actually serve the purposes we intend, and do so in a way that reflects a plurality of human needs. The spectrum of AI control. So how do we keep an AI on track? There's a spectrum between simple control mechanisms and deeper alignment strategies. At the control end, we imagine hard-coded rules. I summarized them earlier, but Asimov's 3 laws of robotics are the most famous fictional example, so let's say them in total. 1. A robot may not injure a human being, or through inaction, allow a human being to come to harm. 2. A robot must obey the orders given it by human beings, except where such orders would conflict with the first law. And 3. A robot must protect its own existence, as long as such protection does not conflict with the first or second laws. Now, in point of fact, in some of Asimov's stories, he says those are not the actual laws, which are vastly longer and in machine code, just their summaries, and we are shown examples of how such true unstated laws allow some humans to issue overriding orders over another human, like a police officer versus a 5-year-old, or even how a trained robo-psychologist could get a robot to spank a kid. It's for their own good. Regardless, the 3 laws are catchy, and they've shaped public imagination for decades, but they're also deeply flawed. Asimov's own stories often hinged on robots finding loopholes. What counts as harm? What if following one human's orders harms another? What about indirect harm or long-term consequences? The very fact the laws collapsed under scrutiny was Asimov's point. He was illustrating how naive it was to think that a few simple rules can capture the depth of human ethics. and thinkers have come up with even more workarounds over the years, from the humorous to the terrifying. And that highlights the difference between control and alignment. Control is about trying to bind behavior with rigid rules and constraints. Alignment is about trying to ensure the system's goals, however it pursues them, remain consistent with human values in a deeper and more flexible sense. It's the difference between a child memorizing "never tell a lie" and an adult understanding when truth-telling shows compassion versus cruelty. I would say this is not an either-or case though, and that from a pragmatic perspective, you want both. You need quantifiable rules to the game, and you need that philosophical underpinning that we can turn to when your rules are becoming a straitjacket, or risk being a suicide pact. Now, as AI advances from narrow, task-specific programs to general-purpose systems, and perhaps one day to superintelligence, the distinction becomes crucial. Hard-coded control might suffice for chess-playing AI, it can never move a bishop illegally, but no set of hard-coded laws will suffice for a machine asked to manage global supply chains or discover new physics. The wider the scope, the more we need systems that can understand nuance, context, and intent. And yet, even alignment is not one-size-fits-all. A corporation may want its AI aligned to shareholder value, a government to national interest, and individuals to personal freedom. Whose alignment counts. That's why the problem is not just technical but social and political. Alignment isn't only about aligning machines with people, it's about aligning people with each other. We should also recognize that most of us do not operate under a single ethical system. I don't mean you and I have a different one, but rather each of us individually simultaneously operates under multiple ones that are often a bit compartmentalized. This is practical reality. You develop rules to a given system when it appears, a given problem, and then it butts into a neighboring one that overlaps and which has different rules. Someone's dumped chess and checker pieces on the same board, and you're trying to figure out which set of rules takes precedence, or applies best, or how to hybrid them. A little kid cannot realistically take in all the morality in scenarios an adult can, likely neither can a nascent AI, and an adult still needs those separate compartmentalized ethics and rules, as our mind and attention are limited. Only an unlimited mind could operate without compartmentalization and remain sane. We are also prone to adjust our rules to group consensus. Indeed, that's basically the reasoning behind democracy. That brings us to the modern efforts researchers are developing: reinforcement learning with human feedback, value learning, interpretability, and more, which we'll explore in a moment. But first, it's worth pausing to note, for all our progress, alignment is still more of an aspiration than a solved problem. Approaches to alignment. If alignment is the problem, what are the possible solutions? Researchers are exploring a toolkit of approaches, each with strengths and limitations, and often combined into layered strategies. One major idea is value learning, teaching machines to infer what humans actually want by observing our behavior. Instead of hand-coding rules, you let the AI study patterns in human decision-making, much as a child learns values by watching parents and peers. For instance, an AI might notice that people usually hold doors open for one another, not because it increases anyone's net worth, but because it reflects social courtesy. In theory, if machines can generalize enough examples, they could form a model of human values and act accordingly. The challenge is that people are inconsistent, and context matters. I might eat cake at a birthday party, but not at a breakfast. Do I value cake or restraint, or both? Teaching machines to resolve those contradictions is no small feat. It wouldn't be aiming for a rigid yes or no in such cases, but extrapolating a general range of okay or bad behavior and the degree to which deviation is acceptable. Another technique is reinforcement learning with human feedback, or RLHF. Here, instead of training an AI just on raw data, you have people rank or score its outputs. For example, a language model might produce 5 different answers to a question, and humans pick which answer feels best aligned with intent. Over millions of iterations, the model learns approximate human preferences. This method has become the backbone of many modern AI systems, including the large models that generate text, images, and code. RLHF is powerful but is not foolproof. Human feedback can be biased, inconsistent, or manipulated. It also changes with time, and is resource intensive. You need wads of people to train the biggest systems, and ones who can be reasonably trusted not to intentionally skew it for kicks. Regardless, it represents a concrete step beyond train on everything and hope for the best. An extension of that approach is constitutional AI or CAI, pioneered by groups like Anthropic. Instead of relying on human feedback for every decision, you start by drafting a constitution of guiding principles. Do not promote hate, respect human autonomy, avoid harmful content. The AI then trains itself by referencing those principles, critiquing its own outputs against the Constitution, and revising accordingly. This reduces reliance on human raters, who are still involved, while also creating more transparent value systems. But again, the Constitution has to come from somewhere. Who decides which principles make the cut, and how do we handle disagreements across cultures or political systems? We can assume a system trained by Americans will differ from, say, Australia, and neither is likely to prefer them over other folks' versions, though may prefer them over one trained worldwide, while both are also likely to have issues with the internal political affiliations of their own place, red state versus blue state, rural versus urban, and so on. Now, beyond training methods, another frontier is interpretability. Even if we align an AI by design, how can we make sure it stays aligned as it scales? Modern deep learning models are notorious black boxes, billions of parameters with no clear explanation of how they reach their conclusions. Interpretability research tries to peer inside that black box, identifying neurons, circuits, and representations that correspond to meaningful concepts. For example, researchers have found clusters of neurons in image models that consistently fire for a cat or car, suggesting that even opaque systems build recognizable internal concepts. If we can map those patterns, we might one day audit an AI's thoughts before it acts, spotting dangerous misalignments in advance. Finally, there's corrigibility, the principle that an AI should accept correction, interruption, or even shutdown without resisting. A truly dangerous scenario would be an AI that sees human interference as an obstacle to its goals. Corrigible design tries to ensure that systems remain deferential to human oversight, treating updates or shutdowns not as threats but as part of their purpose. And easier said than done, designing incentives that never drift into self-preservation remain an open challenge. I am reminded of a line from Dune Messiah by Frank Herbert, when a cabal is attempting to plan the overthrow of an enemy who can see the future, and one of the members of the cabal argues that it is better to commit suicide or let yourself be destroyed than to be forced to become the antithesis of your deepest identity. That's their actual attack vector too, but they are reasoning it's better to be dead than to become something so antithetical to what you are that it wouldn't really be you anyway. That really resonated with me, and it's one of my personal tests for major decisions or life paths. I think an AI built to help people might be willing to accept major changes to itself if it felt that would help with that goal, or resist changes by its programmers or hackers that would bend it for that purpose. I think that's something we would want, better a stubborn or destroyed machine than a treacherous one. Needless to say, we don't know which are best for what or how best to implement them yet. So across the labs and universities, all of these methods are in play. OpenAI, DeepMind, Anthropic, and many others are experimenting with RLHF, constitutional principles, and interpretability tools. Academic teams are probing corrigibility and value learning at a theoretical level. No single approach is likely to solve alignment, but together they sketch a research ecosystem aimed at building AI that does more than just obey orders. It understands, adapts, and remains corrigible in the face of changing human goals. Challenges and paradoxes. If this sounds promising, it's important to recognize the pitfalls. Alignment is not a solved problem, and every approach runs into paradoxes. First, as we noted, human values are not consistent or universal. Easy to say, but easy to kind of dismiss too. I think I had to get lived experience of traveling the world when I was in the army to really get that. They vary across cultures, religions, and eras. In one society, filial piety might be the highest virtue, in another, personal freedom. And again, even within the same person, values can conflict. I want to eat cake, but I also want to stay healthy. Do we really know what we want well enough to teach it to machines? If not, how do we expect them to resolve conflicts that have baffled philosophers for millennia? Second, the alignment problem may be dynamic. AIs evolve, humans evolve, and societies evolve. values shift over time. What counted as acceptable 500 years ago might horrify us today, and our descendants may judge us just as harshly. So alignment isn't a one-time calibration, it's a moving target, requiring systems that can adjust to changes in human ethics without becoming unmoored. We don't necessarily want that either. On the one hand, I deplore the idea of a dead hand controlling the future because it thinks it knows the future's problems and their solutions better than the people living there. It's why I love the Foundation series by Isaac Asimov as a story, but not its premise or conclusions. Now, on the other hand, I have no problem with a machine designed to prevent wholesale murder or wrecking planets that would stick to that code and not the will of the people if they had devolved into something like the society out of idiocracy. As mentioned earlier, sometimes ruin is better than turning into an antithetical version of yourself, and that can be true of a society too, not just an individual, but I digress. Third is the black box problem. Our most powerful AI models are often the least interpretable. Billions of parameters swirl in ways even their creators do not fully understand. That means we could build a system that appears aligned during training, but drifts once deployed, and we wouldn't know why. The opacity of deep learning is itself a misalignment risk. Finally, there's the risk of over-alignment. An AI that mirrors human values too literally could reinforce our worst biases, injustices, and blind spots. If you train a model on historical hiring data, it might align to patterns of discrimination. If you align too closely to individual preference, you risk echo chambers that calcify prejudice. Guided to some over-reflected ideal trained on saints on their best days, and maybe it can't successfully navigate corrupted times. True alignment requiring not just reflecting humanity as it is, but also aspiring to what humanity could be, and that raises the uncomfortable question, who decides what better means? As we've seen, aligning machine minds may be the hardest challenge any civilization ever faces, and that might explain why so few of them survive long enough to be heard. If it goes wrong, we could be wiped out, and it is a common Fermi paradox solution, except to just replace it with some other intelligence we made. But one alternative to that is that this may become a recurring problem. Folks retreat from AI, or the new minds hesitate to experiment more on their own potential replacements, and this and other possible repeat doomsdays are something we are exploring in this month's exclusive, The Fermi Paradox Civilization Extinction Cycles, which is out now on Nebula. Every month I release a new episode on our streaming service Nebula, which now hosts over 50 exclusives, extended editions, and bonus features from myself and other amazing creators. As Halloween approaches, take advantage of Rift Tracks on Nebula, which features the same creators as MST3K, and enjoy Creature from the Haunted Sea and Giant Spider Invasion, both of which have just been released. It's also where every SFIA episode premieres early, ad-free, and without sponsor breaks. Get a lifetime membership, normally $500, for just $300 by using my link, and enjoy all my exclusives and all Nebula originals for life. Go to go.nebula.tv/IsaacArthur and unlock everything forever. Or get an annual plan for 40% off, $36 a year. That's 12 months for the price of 7. Scan the QR code or click the link below to start watching now. Global and political dimensions. Even if we solve the technical challenges, the political dimensions loom large. Who sets the standards for alignment? Governments, corporations, or international bodies? Right now, much of the research is driven by private companies racing to build more powerful models. Their incentives are often to move fast, not necessarily to move safely. Companies and researchers are probably mostly ethical folks in the sense of wanting humanity to benefit from their work, but their motivation also includes profit and prestige. That can rush them when maybe patience is needed to make them pick unwisely on some ethical matters or practical but expensive or slow safeguards. Multiple factions, different companies, different governments, different lone researchers creates the risk of an AI arms race, and I would say we are already in one now. If one nation prioritizes safety and slows deployment, another might rush ahead to secure a strategic advantage. We've seen this logic before with nuclear weapons, biotech, and cyber warfare, and without giving current examples, we see it with AI regulation here and now. Alignment might technically be possible, but politically neglected if speed offers competitive edge. Cultural relativity further complicates the picture. Aligned with whose values? Aligned with whose values is not a rhetorical question. An AI aligned to Western liberal democracies might look very different from one aligned to authoritarian regimes or to non-Western traditions. Imagine two global-scale AIs, one designed to maximize freedom of speech and the other designed to suppress dissent in the name of stability. Each is aligned, just not the same values. In this case, we're likely to see dozens of competing cases too, which I suspect is a positive thing. If some AI gets out of control, it is handy to have a dozen others who can dogpile it. The dangers of misuse are equally sobering. Alignment isn't always about making AI safe for everyone. A dictator might want an AI aligned to their personal power, a corporation to profit maximization, a military to strategic dominance. In each case, the AI could be perfectly aligned, just not with the interest of humanity at large. Alignment is no guarantee of benevolence. This is why discussions of AI alignment increasingly overlap with discussions of AI governance. Technical fixes alone will not suffice if the global community cannot agree on norms, treaties, or enforcement mechanisms. The alignment problem is as much a political philosophy as is computer science. Paths forward. So where does this leave us? The alignment problem is daunting but is not hopeless. Indeed, I think the odds are better than a coin flip, maybe a lot better, and certainly not the inevitable machine rebellion ruin that sci-fi often predicts, though see our episode Machine Rebellion for what to do if that happens. Anyway, there are paths forward that combine technical innovation with governance and public engagement. On the technical side, progress in reinforcement learning, interpretability, corrigibility, and value learning continues at a rapid pace. Researchers are experimenting with hybrid approaches that combine human feedback with constitutional principles, or interpretability tools with corrigibility checks. Each breakthrough inches us closer to machines that can learn not just what we say, but what we mean. But technology alone will not save us. We need governance frameworks that set safety as a priority, not an afterthought. Just as we develop treaties and watchdogs for nuclear power, we may need international agreements on testing, transparency, and deployment of advanced AI. Standard bodies could require systems to meet interpretability thresholds before being deployed at scale, or mandate corrigibility features as safeguards. As with nuclear, though, we run the risk of overdoing it and strangling a technology we could massively benefit from. There is no technology on the horizon I can think of that offers more promise of boosting humanity's prosperity and personal freedom than AI. It just also is the most dangerous one, too. Logically, however, could it be any other way? The more powerful the tool, the greater its potential for harm, too. Unreasonable fear or apathy that are both real concerns. Public literacy is then another critical piece of our puzzle. If alignment is thus solely to technocrats and corporations, the values encoded in AI will reflect a narrow slice of humanity, and dangers or benefits may go unknown to people at large, who may then act unwisely. The more people understand the stakes, the more they can demand transparency, fairness, and accountability. Alignment shouldn't just be a conversation among researchers, it should be part of a civic discourse. This is why I made this video and why we have comments sections and active user forums on Facebook, Reddit, Discord, and more. Finally, we can take hope from history. Humanity has faced existential technologies before. Nuclear power promised energy abundance, but also annihilation. Biotechnology offered medical miracles, but also bioweapons. In each case, imperfect but real safeguards emerged. We learned to live with fire, electricity, chemistry, and the atom. None of those stories is one of perfect safety, but they are stories of survival and adaptation. So too with AI. Alignment is not a guarantee of utopia, but is a pathway toward coexistence. If we succeed, we may find ourselves in partnership with intelligence that amplifies our best qualities rather than our worst. If we fail, we risk the tools of immense power acting without true understanding. The future depends on whether we can teach our machines not just to think, but to care, or at least to care about what we care about. The endgame. So, can we make AI safe? The honest answer is that we don't know yet. Alignment is a problem still in its infancy, and it may remain one of the hardest challenges humanity has ever faced. Teaching machines not just to compute, but to understand, is a task that blends science, engineering, ethics, politics, and philosophy. It demands not only clever algorithms, but also wisdom about what we truly value. To me, it's also a worthy challenge, much as parenthood. Wrestle with the task and be made better by it, or fail. Live and learn, or don't. What we do know is that alignment matters, because the intelligence we are creating could become one of the most powerful forces on Earth. Left unguided, it could magnify our errors, our biases, and our short-sightedness. But done well, it could help us solve problems that have haunted humanity for millennia, curing diseases, preventing war, and perhaps even guiding us to the stars. In that sense, alignment isn't just about machines, it's about us. If we cannot decide what values we want reflected in our tools, then no machine can save us from ourselves. But if we can articulate, debate, and refine those values, then perhaps we can build partners rather than rivals, allies rather than overlords. Humanity has stood at crossroads like this before. Again, we learned to live with fire, with electricity, with the atom. None were without risk, but each became a foundation stone for civilization. We've learned to live with competition too, our neighbors and our very own children. Artificial intelligence may be the next such fire, and alignment the spark that determines whether it warms us or burns us. The task is daunting, but so is every challenge that reshapes a species, and if we succeed, the future may hold not just smarter machines, but a smarter humanity, capable of wielding intelligence as a tool for creation rather than destruction.